GoToWebinar, and you'll be able to access that through our website. Everything that we're going to be talking about and showing today will be available for discussion at ISC West this year. Yes, we will have a booth. Charlotte, can you give me the booth number? I don't have that off the top of my head. And our topic today is going to be video harvesting. There we go. Our booth number will be 11131. That's 11131 at ISC West. And I'd be welcome to answer any questions that you have. I will also be at the RGB Spectrum booth. RGB and HauteSpot are partnering on the delivery of this some solutions for video harvesting, which we'll go into a little bit later. So let's begin. What is video harvesting? We're going to be talking about basically how you can gather remote video from disparate, unconnected video sources over the internet. And there's a lot of challenges. We're going to talk about the challenges. We're going to talk about some of the things that you can do and talk about some of the opportunities. We're going to go through a definition of what video harvesting is. We'll talk about source locations and source types and network issues, latency issues, some of the challenges that you have as far as business requirements, and then we'll talk about a solution that we're putting forward that we think is pretty slick and definitely will meet the requirements that most police departments and public agencies would have, as well as central station alarm companies in this respect. So what is video harvesting? And that's a term that I actually coined. We were looking for exactly what to call this. Our friends at Milestone, who we've worked with to develop this technology and this concept, wanted to call it video extraction. I thought that was a little excessive, kind of sounded like going to the dentist. And so harvesting sounded a little friendlier. The idea is that we can go ahead and access remote video surveillance devices and systems, be they NVRs, DVRs, VMSs, PSIMs, cameras, set-top boxes. They could also be remote systems, such as access control systems or call box systems, anything that has a video output. And the idea of extracting the video is that we need to get all of these different sources into a standardized format and a standardized protocol, which can be ingested by whatever the central repository, the central VMS system is that either a central station alarm company or a police department is using. And then we also need to be able to put it into a standard format for storage purposes. And we need to be able to access these systems both remotely and locally, and be able to recall the video, particularly when they're trying to apply evidence to a case and seek convictions based on video systems. So the challenge comes when a central station alarm company or a police department or a federal agency wants to access the video from a number of different sources. And those sources can be anything from churches to fire departments to police departments. I may want to watch metropolitan cameras. I may have other metropolitan sources like traffic departments. We have schools, stores, hospitals, office buildings, factories, and parks, and any other location that you can imagine. So The first challenge is that you got to make sure that whatever location you're going after to serve up has some level of connectivity. And that connectivity has got to be to an IP cloud. And that connectivity could be a number of different ways. And actually, my slides are out of sequence. Let me go to the next slide, and then we'll come back to this one. And so that connectivity could be via DSL, could be via broadband wireless, it could be via satellite, cellular, cable modem. There's all sorts of different ways that I can get broadband in and out of a facility. The challenge with each one of these different methods of connectivity is they may have latency issues, they may have bandwidth limitations, they may have variability in the amount of bandwidth, so they may be bursty, they may be asymmetric. When you're talking about DSL and cable modem, those technologies tend to be highly asymmetric, so what's coming out of a building may be much less bandwidth than what is going into the building. And so, we've got this challenge that I've got lots of different locations, and I need to connect those different locations in lots of different ways. And I can't have different solutions for all the different venues that we're talking about. The initial trials that we're in right now, we've got a police department back east in the state of New York. They're talking about 800 different locations to start with, mostly schools, churches, and hospitals. We've got a large metropolitan location out here on the West Coast that we're talking to. They're looking at roughly 10,000 different locations. And you can't have a different solution for each and every one of those locations. So we need to be aware that we're looking at a universal way of connecting over many networks to many different destinations. Now, to go back one slide, let me go back here. Previous, and one more previous. And to compound this, we've got a variety of different sources. And those sources are generally pre-existing systems. So I've got analog video recorders, I've got IP video management systems, I've got analog cameras, IP video encoders that may be attached to analog cameras, I've got IP cameras, I've got digital video recorders, and again, I may also have other kinds of computer systems, access control systems, life safety systems, elevator systems, all of which may have embedded video, which the police or your central station management company may want to get access to. So I need a very, very flexible means of getting into all of these different systems. Okay, so now we're going to jet back through our many networks. And typically, this is sort of the architecture in general terms that you're dealing with. I've got a remote video system of some type. It's going to be connected to a private network, which will have some type of broadband router. And that may be a cable modem, it may be a DSL modem, it may be a cellular LTE modem, maybe private Wi-Fi or other type of wireless network delivery. But generally, these are all connecting to an IP cloud, the internet. And somewhere on the network, I've got a gateway firewall that's at my main office. So let's say that that's a police station. So there's a police station router that's controlled by the IT department for the municipality, for the police department. And behind that firewall, I've got my central video management system. So in these types of situations where I want to do safe cities, I want to be able to reach out and grab video. I don't want to do persistent monitoring. I'm not going to monitor 10,000 locations if I'm a police department. I'm going to respond to alarms, emergency calls, 911. When that call comes in, I want to make an outbound call. And I want to be able to make that outbound call from my central management system out to the remote system. And the problem is that that remote system is also behind a firewall, and it's behind a broadband router. And I may not control that broadband router, and I may not control the remote video management system. So I've got a problem. Those remote routers are running dynamic addressing, so they may be getting an address that's not persistent from the ISP that's providing service to them. If I'm doing cellular, that may be what we call IP mobile or mobile IP, where the router connection between the cellular provider and the cloud is actually going from IPv4, which is our typical, 192.168.1.1 type of address, to a IPv6 addressing scheme. And then they're tunneling IPv4 over IPv6. So trying to make that inbound connection from a public network requires that I may have to pay the ISP for static addresses. And a lot of the small companies, a grocery store, a gas station, a school, may not have the resources to financially afford, or the carrier provisioning that would allow them to technically have a inbound static address. But once I get that inbound static address and I can connect to a known destination, I still have the issue of that router may be running network address translation. So at that point, I need to get the IT department involved to have them do port forwarding through NAT. So you've got a compounding of problems of how do I make a on-demand outbound connection from a fixed location, my police department or my central station alarm company, out to these remote sites. And the way that you really need to do that is with a VPN tunnel. So a VPN tunnel establishes an outbound connection from that remote site through the remote site's broadband router over the cloud to the remote firewall gateway at the central station site. That VPN then will tunnel my network connection from that remote site back to my central server. The net effect is that my central server will see that remote system as if it were on a local network. That lets me know not only that I can reach that system, but I can assign a known private address to that system. And that gives me the ability to dial in and connect to it. So what the VPN tunnel does is it allows me to make a persistent connection out from the remote site. I don't have to send any traffic over the VPN until I want to look at the video. So I can actually send keep alive sessions over that VPN that are just very, very low bandwidth, a couple of bits per second. And that couple of bits is enough to keep that tunnel open so that when I want to make that persistent connection back and use the tunnel to get back to the remote site, I can. But I don't incur any bandwidth charges from the ISPs for having that tunnel in place. So, the connectivity strategy on this is basically to use VPN tunneling. And that would be something that you need to be considering in this. Now, the other consideration is latency and delay. So one of the things that a VPN does is it adds overhead to my connection. And it does that by encrypting the connection. And then basically, if you think of a VPN as mail, and I've got an envelope or a courier pouch that goes across the mail from one building to the other, and everybody sends their envelopes inside that package. So I may have an envelope that's assigned to Charlotte, and I put an address on that envelope, and then I stick it in the courier pouch, and that courier pouch has another address on it that tells it what building to get that pouch to. So that all adds overhead, and that's what we call header overhead or addressing overhead. And different VPN technologies do use different networking protocols in order to make sure that they made their connection. So you can use TCP, Transmission Control Protocol, which is a highly reliable protocol to send data over the internet. And basically what happens with TCP is every packet that gets sent gets an acknowledgement from the remote end that it received it. And that acknowledgement gets sent back to the sender so that he can either resend if the packet got lost, or he can go and send the next packet. Well, the net effect of running TCP over an internet for video over a cloud is that I've got to wait for those packets to return before I send the next one. So that's typically a problem for cameras talking to VMS servers, but it really becomes a problem when you've got a VPN. Because if I've got that TCP, even if I use UDP, which is an unacknowledged protocol, that basically I send the package out and I hope that it gets to the remote destination, and it's up to the application at the remote destination to figure out what it got or what it didn't get. And if it didn't get something, it's going to send a message back to me to resend, whatever didn't get there. Well, the performance of UDP over a WAN can be much, much better because I'm not waiting to send the next packet for acknowledgement of the prior packet. So I can send a whole bunch of data and then do selective resend. My little cartoon over there, which I stole from somebody else, kind of explains TCP versus UDP, and basically TCP is dealing with the specific packets and making sure each specific packet gets across, whereas UDP is sending packets and hoping they get across and relying on the receiver to tell them when they didn't get something so that they can resend it. It's just a cute way to remember that. Video streaming over wide area networks is most effective when it's done using UDP and unicast, because that means that I'm sending data without acknowledging every single frame and waiting for every single frame to get to the destination. So UDP is preferred. You can also use IP multicast, and this is particularly helpful when you have many destinations that you're trying to send to over your VPN. Let's say that you had 2 or 3 different people that wanted to watch the remote stream without even going through the VMS at the police department. You may want to use multicast, in which case the packets get sent out and there is no acknowledgement from the receiving end. Just basically the receiving end does the best effort to try to receive the multicast and reassemble the packets into a video stream. So TCP versus UDP is important for latency and transmission reliability, and you've got to balance reliability versus latency. When you're using a VPN, you want to use a UDP protocol, And ideally, you want to stream the video as UDP through your UDP tunnel. Right now, there's two broadly available VPN protocols that do this. One is called L2TP, and one is called OpenVPN. And both of those use UDP protocol, and they can be used to create actually layer 2 connections, networking layer connections, from the remote site to the central server location. And those protocols add very, very little latency when you're streaming video, and they're very, very efficient. A common protocol that's being used right now from cameras back to VMSs is HTTPS or SSL, the Secure Socket Layer Protocol, which is a TCP-based protocol. The problem with that protocol, while it's very secure and it's actually easy to deploy because it can actually be run to look like it's typical web traffic, the downside of it is it uses TCP, which means that it can actually suffer from latency and delay when you're going over wide area network connections. For that reason, we'd recommend not using a VPN based on secure socket or SSL, and that would be HTTPS or SSL tunnels. HauteSpot routers support a tunneling protocol called SSTP, and certainly you can use those, but we'd recommend using L2TP or OpenVPN. And the last element of the VPN connection is what we would call the encryption, and you can actually run VPNs without encryption. And you can run weak encryption, strong encryption, or no encryption. And encryption, again, will add to the size of the packets, and it will also add to the overhead in the headers for your transmission. So really, unless security is a big concern about people intercepting your video, and really because you're doing an outbound connection on a on-demand basis to a transient source, the chances that you actually need strong or even weak encryption on your VPN tunnel are fairly low. And so we would kind of say that, you know, if public policy will allow it, don't use any encryption on your VPN tunnel when you're doing this this connection, and allow either your application to run the encryption or turn on encryption on demand when you do have sensitive data. But don't, as a general rule, run strong or even weak encryption on your video links. And I'm running behind, so I need to get moving a little faster. Okay, so we've identified a bunch of challenges. You've got the question of, you know, what are you going to connect? You're going to have the question of where are you going to connect, how will you connect, and who will manage the connection. So there's lots of questions that are going on out there, and a lot of those are going to be procedural. What will you connect really comes down to what systems are already in place, and do I have the ability to replace the remote system with something that's more friendly to the VMS that I have? Where am I going to connect? Well, you know, that again comes down to placement of where the VMS is relative to broadband connections. A lot of times your VMS on site is not where your best broadband connection is. So you may want to move that broadband to a location that's better suited to, or the VMS to a location that has better broadband connectivity. How will you connect? Again, it's that question of VPN and who will manage the connection. You know, it takes two in this kind of an architecture. You need an IT guy on site or somebody that's responsible for the customer premise equipment that's going to take ownership of it. And I can't solve that problem. That's a procedural problem for you guys. But there are definitely challenges out there. when we're talking about public agencies like police, federal law enforcement, etc., you've got the question of who owns what equipment. If I'm connecting to somebody's VMS service, and all of a sudden they've given me full access and control to their VMS so that I can go in and rewind and play back and do everything else, there may be a push from the remote site for me to take ownership of their equipment and their network. And most police agencies and even central station alarm companies may not want to do that. You may want to just say, look, we're going to look at it. Looks like I may have some network connection on my my link. If audio is not too good, we'll try to fix that. There's not much that as far as feedback, I'm not seeing where my audio is not so good. So we've got the ownership issue of who owns what equipment. We also have the points of demarcation. Where does responsibility end and start? And so we need to look at that as well. Where does the police presence end? Where does the alarm company's presence end? You've got probable cause. If I'm a police department, I need to look at when am I entitled to get into that video and under what conditions. And so I may not want to have always-on connectivity simply because, that isn't justified with a warrant. I need training. How do I, if I'm connecting to many, many different video management systems, how am I going to train all the users of that system? If I've got the police and I'm going to 10,000 different companies and different sites, that means that I'm probably going to have several thousand different VMS systems to connect to. How could I possibly learn how to manage them all? And you can't. I also have the issue of chain of evidence. Who takes control and when and how was the video gathered? If I've got different systems out there, I may have risk as to the quality of the video that I'm bringing back and the admissibility in court of that. And then the last question that we're all aware of is privacy. Am I taking access to a system, or is the owner that I'm going into their premise and pulling video out at their bequest? So, you want privacy to be observed. So video harvesting requirements, it's pretty straightforward. You want it to be easy to install. We want it to be cost effective. It needs to be manageable. It's got to be practical. You can't have something that's so cumbersome that nobody can use. We need it to be network compatible. It needs to be able to go through these firewalls. It needs to be able to be reached over the internet. It needs to be able to connect reliably. I want high resolution. I don't want to take a high-def VMS and shove it into a system that takes it down to 1/6. You want that video to be high quality. I want the high frame rate. I may need to get a license plate, or I may need to get a face for evidence. And if I don't have the frame rate that was native to the original system, I've kind of given away the whole reason for doing the system. It needs to be secure, as we talked about, with VPNs, and security doesn't always necessarily mean encryption. I need to be able to delegate responsibility and draw those lines of demarcation, and it needs to be a universal solution. So just, some of the options that you have would be that the police have access to the internet and that they're able to dial out on demand to an IP address where the video system has a embedded web server and I'm able to remote into it. Well, the first assumption is that that system's on the internet and that it's capable of being connected to. That I've got static routable internet addresses that I can reach, that I know how to connect to it. I may need port forwarding on the firewall. The police then would have to know how to use the remote system that they're logging into. The owner would have to allow and create a user account for the police to log into the system. And, you know, they are going to have to know how to connect. And that's fine if I only have a limited number of systems, but if I'm talking about 10,000 in the city, that becomes impossible. So option one, yeah, you could kind of do it, but you know, the disparity, the number of systems and the homogeneity that you have is pretty tough. Option number two would be have their server push information directly to my server. And that's using an internet connection to link the two systems together. Well, that's great, but again, the video systems need to be network capable. Again, you need to have connectivity somehow between the two sites. You need port forwarding again. I need standards, and this is probably the biggest problem, that the two systems have to be capable of interconnecting. And that basically means that they are doing on-VIF out, that they've got some kind of standard interface for sending their video out. Most VMS systems don't want to do this because they don't want their video to be harvested by other VMSs. Yes, you can do that with a PSIM, and a PSIM, a Physical Security Information Management System, allows you in software to connect to lots of different video management systems. The problem is, again, if I've got 10,000 systems, I can't possibly have a PSIM that's going to connect to them all. So I need something that normalizes the protocol that I use to connect all these services. I need some degree of interoperability between the systems. I need the command structure to match. Again, the owner needs to allow access to the remote operator to get into their system. Generally, that connection should be persistent, and that the two systems are probably going to be interconnected, which means that you may have high data volumes because you're sending video across that pipe. That isn't necessarily the case, but it's kind of a typical case, because otherwise I may get alarms that say I'm not getting video from that remote site, and I'll get a bunch of spurious alarms on a bunch of remote sites that I'm not really concerned about. So you probably do need secure tunneling in a VPN even for this architecture. And of course, HauteSpot can certainly help you deliver that type of a solution. Our third solution, which is what most integrators and manufacturers would like, which is a forklift replacement, that I go in, rip out the VMS at the customer site and put in mine, the one that's compatible. Of course, that's got the obvious problem that, you still have to have the connections, you still have to have routable addresses, you still need port forwarding, you still need a secure tunnel to link them. But the owner has to allow you to have access to their system. They may always have the connectivity, and the main thing is that you're forcing the owner to buy a new system, and there's going to be a lot of pushback against that. So is that really pragmatic? It might be for large sites. It might be where you have that as an option, but in general, that isn't really much of an option. So that gets us to what we're promoting, and again, this is the conclusion that we'd like you to draw. If you have an encoder which can connect to any video source, and that video source can be VGA output, DVI output, DisplayPort, HDMI, or even NTSC, your standard component or composite video. A TV signal. If I've got a video signal, I can encode that. And I can encode it to a standard H.264 string. And I can present that from that encoder out over RTSP, the real-time streaming protocol, in a standard format, on-VIF compatible format, that would allow me to send the video in a standard format back to the central server, and the central server would treat it like a camera. So what I end up getting is a encoded view of the desktop, the output, the local console of that remote VMS. And I encode it at the native resolution of that screen, and that can go from VGA resolution 640 by 480 up to 1920 by 1200. My 1080p, my high definition video. I'd have a VPN that's doing outbound dialing and maintaining that remote connection. The universal encoder has local record capability. So what I would do with this encoder is I would record the last 24 hours, 48 hours, whatever time period I think is important, and I would record it to a local source on that remote encoder. And that allows the police or the central station to go into that local file system on the encoder and pull video off without ever having to involve the customer. So I don't need to learn how the customer system works. I don't need to know how that system is integrated. I don't need to do anything. Whatever has been shown on the desktop, that's what I'm going to get. Now that would allow me, why is it doing that? Okay. That would allow me to access the system, albeit maybe not at the highest resolution possible, but I could then see, do I have the video that I need? If I need to go back to the original source system, I can do that. But in most cases, I have a standard way of capturing that video, moving it back to the central repository, grabbing evidence in a standard way that has been vetted by the court once and is usable across thousands and thousands of different source locations. I want to make sure that my system has secure tunneling, VPN. The owner probably still needs to allow remote access, and that in this case would be the owner needs to make sure that the console for his system is pointed at the video that the police want to see, which would probably be your 2x2, 4x4, whatever kind of matrix view that the VMS is cycling through, etc., for them to remotely look at. It could be persistent, always on, but it doesn't have to be. You can do on demand because I've created that inbound VPN tunnel. And so our solution looks something like this. I've got a remote system. In this case, I've got an IP camera, but it could be a VMS, could be a DVR, could be analog, could be digital, doesn't really matter. Goes into my universal encoder. The universal encoder has local storage. That local storage and universal encoder are plugged into my VPN client router. That VPN client router connects to broadband router over private network. It creates that secure tunnel from the remote site back through the cloud to my central manager, and then I can grab video on demand by going back from the central site out to the camera. And I have the ability to do analog cameras, digital video recorders, remote video management systems. If they're IP capable, great. If they're not, I can still grab the video off of them. It could be an IP encoder that's sending the video, and in which case I don't need my universal encoder, but if I've got an encoder, I can put it on the VPN. And so, as I said, we're partnering with RGB Spectrum to use their DSX H264 encoder. And it's an encoder that will accept VGA DVI, HDMI, DisplayPort, whatever type of video you have, it can grab it, encode it, and transmit it. It can also record it. It uses a H.264 high profile, so it gets 422 color. It supports the RTSP format, and it's compatible with a lot of BMSs. We've tested it with Milestone, Exact, Genetec, but it should work with almost anything. It works with VLC, Windows Media Player, etc. It can do concurrent recording and streaming. It's got event marking, so if I want to go back and go into a specific recorded file off of the RGB or off of the USB, I can mark those videos and playback and grab them for remote transmission. It'll write to its local USB, and it'll write to a NAS server. It's got some other interesting things. These were developed for the military for use in training. And so they're designed to be synchronized across multiple encoders, so I can have them all use the same timestamp, and I can play back, because they can also be used as decoders. I can play back with time synchronization across multiple encoders, provided they're all using the same time source. And it's got a pass-through connector. So you plug this into your VMS, and then you plug your monitor into it, and you can see exactly what's being recorded, and nobody even needs to know that this device is there. And there also is a version of it that has BNC connectors. I would say in most cases, if somebody's going to go with a BNC, encoding NTSC or PAL video directly from cameras, they probably aren't going to be as interested in these products because there are much lower cost security-oriented products available. And then, of course, you need your VPN router. And we are releasing a new version of our HauteLink VPN. It's an intelligent programmable router. It's got 10 ports, 5 ports of gig Ethernet, 5 ports of 10/100 Ethernet. It's got a fiber module, so you can use that for a connection into whatever network you've got. It's high performance. It's small form factor. It comes with integrated Wi-Fi, 2.4 gig. It runs our TDMA-like protocol, so if you wanted to hook cameras up to it and have the cameras coming back and use this as a way, a stepping off point for access to a customer premise facility, you could do that. It supports USB cellular connections. So if you have a location that doesn't have broadband, you can use LTE, UMTS, HSPA, EVDO, whatever type of cellular connection there is. It has USB storage, and it can be a NAS server, so you can use this as a point for convergence of storing remote video. It's got central management, and like I said, it's been tested with a whole bunch of different VMSs. And I hope that this was a clear presentation and that I answered most of the questions about how you might do this. I've got one question that came in. Please discuss the potential for using this overall solution with moving vehicles, buses, trains, above and below ground. And yes, you could put the HauteLink 1000 or our HauteMobile router in a vehicle, and it can you could put the encoder directly into an in-car vehicle system, encode the output from that in-car vehicle system, whether it's a Panasonic arbitrator or a TransView system or any of the March network things. Any kind of system could be used for this. And using cellular, you could absolutely bring this video back over a secure VPN connection on cellular. The beauty of using our intelligent router is that it will fail over between wireless connections and maintain that connection from site to site. So you could actually have Wi-Fi connections and cellular connections that the vehicles roam between. And that would be something that I would encourage you to discuss at ISC. We have another question about how can we access the archive of this webinar. That will be posted on our website, and we'll be putting that out there. My name is Bob Ehlers, and I am on the board with HauteSpot, and you can reach me at any time. My last name is Ehlers. My email is bob@hautespot.net, HAUTESPOT. Show option 3 slide one more time. Okay, we'll go back to option 3. Right there, forklift replacement. And was there a specific question about the forklift replacement? No questions. You just wanted to see the slide. You know, and it really comes down to you know, the site that you're going to. This may be the best option if the customer can afford it. If you know you're looking at something like, let's say you're doing an Indian casino, and they already have you know, their VMS installed, and you're the public safety organization for the tribe, and they want to get access to that. You know, you're not going to get them to rip out their security system so that you can make it compatible with yours. Chances are you're going to have to go in and figure out ways to interconnect to their system. And so casinos are actually a great example. I got a question here. Which option is the most cost-effective and time-effective? You know, cost-effective, it's really going to depend on what system is at the remote site. So if that system is already natively capable, like let's say that you're using Milestone at a remote site and you have a Milestone server at your central site, well, that's going to be the most cost-effective, is put in a VPN router and connect the two. If, on the other hand, you're talking about lots of remote sites, probably our option for the universal solution is going to be the most effective. Okay, next question. So to have a DVR, NVR with remote vehicle inside, we can use a VPN solution with cellular data card as a backup. Absolutely, yes. The L2TP and OpenVPN both work very well over cellular clouds, and it will automatically, and you can have the unit configure the router to switch automatically between cellular and Wi-Fi. So as the vehicles come into the barn, the police station, whatever, we can help you get that done. Is there any carrier restriction? Not so much, but there are restrictions on the modems that are used. We have a complete list of the modems that are supported. We can support both domestic and international. We've got these systems running in Singapore, in Malaysia, in Dubai, in Saudi, in Europe. They've run with a number of different carriers, and we've been able to use systems you know, that are running over 3G or even 2G. When you get down to 2G and 3G, you really need to start looking at solutions more like the HauteSpot MVE, the Mobile Video Edge system, which does rate adaptive transcoding and deals with very, very narrow pipes and very, very erratic connection speeds. Do we offer configuration support and tech support on getting this connected? Absolutely. That's what we do. You know, we are not the cheapest solution in the market. If you want to buy plastic, there are definitely customers out there, vendors out there that will sell you something that's less expensive. But call them for technical support, and you'll see why we're not the least expensive. We build products that are highly reliable, highly configurable, and then we train our integrators on how to use them, how to get them configured, and make you as expert as we are in using those products. Are there any other questions? I ran a little long. This is supposed to be a half an hour. It ended up being 50 minutes. I'm going to put a poll out right now, and I'd just like to say, was this useful? We certainly are refining our webinars. We're doing more topics. We're hoping that we're going to see more people interested in these things. I understand that this type of a topic has a narrower interest group than maybe some topics, because not everybody is dealing with police and central station alarm. All right. So I got about 70% of the people voting, and 92% said this was useful. So thank you. The other poll that I wanted to have was, do you think you'll use this information again? And how would you share it? We're going to, like we said, post the seminars up on our website, and they'll be accessible. We'd like to know, would you like this in a PDF or, a YouTube link that you could send your customers to? And I guess that's about it. Unless there's any other questions, thank you very much. You want to probably come and visit, HauteSpot, and we can give you information about how to set this up. We can give you information about how to configure your system. We can give you quotes on how to do this. I'm hoping that this will be available in just a few minutes, because I'm going to stop recording and post it almost immediately. And of course, that only happens if I work it. One more point. Okay, what's the point? One more pool. Oh, poll. I'm sorry. One more poll. Okay, I got to do one more. What do you think about the length of the presentation? Did I ramble on too much, or was this good? Okay. Yeah, I kind of think it was probably a little too long. But most of you said it was just right, so thank you very much. And again, if you have any questions, send your questions in to support@hautespot.net. And if you want a quote, send something to sales@hautespot.net. Thank you very much.